Alright, welcome to an ultra rare early morning video. So I'll be continuing with use case 8. So I'm going to clear out the cells and run down to where I left off last in the book. Now we do have a problem cell here that I spent some time troubleshooting. I got it to run without errors, which doesn't necessarily mean the problem was fixed, but I'm hoping it's enough for now to move on. And then if there is a major issue with it, we will see it because the results will look quite a bit different. So let's try to get down to this print log Y train cell. Oh, right, and then the kernel dies here. So this is one where we might need to just skip this cell because the kernel dies. So, you know what? Let's do that for now and skip that cell. And then we want to get down to that print statement here instead. So let's skip that cell for now. And then get down to the print statement. I'll print out both of them. Alright, so let's keep going. Now we can evaluate the difference between the log message in one of the positions in our Y train matrix versus the corresponding now predicted. There we go. Log message there. There we go. Log message, interface changed, and notice how the formatting is different now. The above is a quite good example of the model predicting and reconstructing a good portion of the log, but then there are certain parts where it has challenges and fails. The level of entropy in each position in the sequence we are trying to predict is not homogeneous. Because of that, the model is not equally successful across the entire log. We can run all our results through a function that can estimate the accuracy on a per position basis. Alright, so there's a graph. Let's check it on the notebook. So looks like there was an error. Yeah, so there's a key error here. We have a list-like key. So this here, I don't think can be put in as a key. Let's see what that looks like. Let's do a type on it and then print it out. All right. Okay, and we'll comment out this line to make sure to try to narrow it down. Okay, so it's actually logging out. So it's actually erroring out on this line here. So it looks like yeah, so something's going on here. So it's saying that this key must be a list-like key. I guess I'm curious why that is the case. What happens if I comment out this portion here? There's still a key error, so we definitely know that it's this next log here is the problem. It's a list-like key apparently. What if we do a dot at? That's still a problem. What about dot key? All right, so instead of guessing, let's see what options we have available for events df. So we're gonna do a dir events df, and then comment out this line. Okay, so let's try this get method on it. There we go, and that was the answer. So now we should be able to oh, so now we've still got a problem here. Okay, so I think we need to do a dot get here as well. There we go. So now we can print out events df. So events df, it looks like it's a none type or something like that. Oh, yep, so it's a none type now. Well, let's print out not last mask. Okay, and then we'll get rid of this line for the error. Oh, so we still got a problem here. Huh, and that worked before, but now it's not working. Oh, you know what? It's because we redefined it, so we need to go back and define it again. Yeah. Alright, so I'll just run all the cells again. I mean, this is the only use case I haven't been able to get to run all the way through so far, so it's not necessarily a complete loss to move on from it. Alright, so as we can observe in the figure above, there are certain areas in the log that the model is predicting very well. The first part of the log is the date, and given the dataset corresponds to a few hours worth of logs, the date is always the same, so the model has very easily learned what to predict there. Same happens to the last part of the log. It is frequently zero padded, so the model can easily learn that. Then, for the parts in between, it has certainly challenges to learn some of it. There, we have definitely room to improve by trying other techniques, other encodings, or other assumptions. As I said, my goal was to show you the methodology and reasons for each step, rather than trying to solve the problem optimally, which certainly I did not. Nevertheless, at least you can see now how to prepare log data and define and train a model that can, with some level of accuracy, predict what the next log is going to be. By making the model learn characters and not words, or even not simply the type of log, abstracting the details, we have made the life of the model much more difficult, but at the same time, we have seen the process in more detail. So this section really isn't even meant to be running seamlessly anyway. It's meant to be a kind of almost a broken notebook that really doesn't give you a perfect result. It's just to demonstrate this concept. So I feel like troubleshooting this really is going to be more trouble than it's worth. We also have a section that really relies on using a Google Colab notebook rather than local hardware, because this training really should take 5 minutes per epoch, so we really won't be able to I mean, we could set it down to like 1 epoch and see if my machine can handle that, but it's really just not meant to be that way. So here we've got the problem again. This is really not the right way to do it. We can see we get a not scriptable error if we do it that way later, because we define it as a none type. And that's not the way to do it. But if I change it back to this, then it complains about what is fed to it here. And then we don't have those complaints here. So there's something wrong with this next log here that hasn't been defined correctly, or so there's some kind of issue with that. So I'm not sure what's going on with that. We can't run the cell again because that events df was defined as a none type, so we have to go back and redefine events df. So it was defined all the way back here, so we basically have to run the whole notebook again. So this is where we redefine events df. It's no longer a none type, but we can see it's going to take quite a bit for it to complete. So I'm willing to cut my losses with this one. It's just meant to be a incomplete representation. It's not meant to be a perfect book that works perfectly and gives you perfect results. So for me, it was just too much, requires too much horsepower. Don't have that kind of horsepower to do it. So I'm going to move on to the takeaways now. Some of the takeaways from this use case that I would like you to remember. NLP has a lot of potential for networking and clouds. Lots of use cases and data types that can leverage these techniques. Syslog messages are a perfect example, and how to learn, in this case, patterns that lead to a prediction of what the next log is. Data representation is one of the key steps in any machine learning project, but particularly important in NLP. There are multiple ways in which we can transform a text into numbers. How we do it will depend on the use case. Dictionaries are tightly associated with your trained model. Keep them safe. If you lose your dictionary, you lose your trained model as well. The more input you add to your model, 2 logs instead of 1 for example, the more context you offer and more opportunity to learn and capture patterns. In NLP, natural language processing, this may also multiply the input size because of the large one-hot encoded matrices. You may very easily struggle with memory, both CPU memory as well as GPU memory. Of course, with access to a much larger compute or cloud infrastructure, this will not be an issue, but if you want to play on your laptop or Google Colab, be aware that you can easily hit some limits. And we saw that. I ran into a memory issue. That's why the kernel kept failing. And in fact, we can probably see that here going back. So yep, the events have been redefined. So we're all the way. Oh, actually, I think it's probably still working. Let's see. Nope, it's been redefined. So we're coming all the way down. Yeah, so let's hit let's hit run some more. We did get this one failing. We've got a key error here for next log. So I don't know. I mean, this is where, yeah, so this is where my fix to this problem cell didn't work, because there's an issue now where it doesn't have next log anymore. So so this didn't populate. I guess we're not going. So let's try this. This might be interesting. Let's run this cell again. All right, and then take a look at our data frame, and now run it like that. Okay, so that seemed to help. We've got our data frame now. So okay. So maybe my logic was just off. We've got a graph that looks the same as was here. Oops, so this is a wrong graph. This was a while back. Yeah, it's too far back for me to go to. Oh, here it is. Yeah, so it looks, the graph looks the same. So I think that was the solution, just my logic was backwards. Okay, so here's that all-important dictionary. We can see we've got different values now. So it really depends on getting those other lines to work correctly. Okay, so now we're doing something that takes a bit of time. There we go, that's done. Dot shape, yep, 208, looks good. All right. Okay, we're doing something a bit intensive here. Take some time. Looks good though. Okay, and this is the cell where the kernel dies. So I'm not sure if we need the history. I might just comment out this cell if it dies again. So yeah, it looks like we don't need the history, so I'm gonna try it, and if it dies out again, then I'll just skip that cell. Yeah, so I don't have enough resources on my computer to run that cell, so we're gonna skip it and go to the next one. Okay, and now my model is not defined, which is interesting, because it's defined here. Oh, you know what? It's because the kernel died. All of the results of the variables and everything like that died as well. So we have to repopulate the notebook with the results of the prior cells. Okay, so now this cell is all commented out. So when I come back, we'll do results evaluation, and we'll get the accuracy score and compare that with what was in the book. But for now, further work. There are multiple areas to explore in this use case, and it clearly has a lot of room for improvement. The data representation could be made in words and have some pre-cleaning to eliminate certain characters, etc. Similarly, you could plan to predict not based on just the previous log, but on 2, 3, or more. More context will facilitate learning. In terms of the prediction, we have focused on predicting the raw log, which was a fun exercise, but a more practical approach could be to predict the type of log. In that sense, some log classification could be done for the logs, so then the prediction task could be based on the class and not so much on regenerating the details of the text. This would simplify the models and would allow you to train with more data as there were more logs available. Of course, you could try this use case with your own real logs, not with Sans generated ones. Alright, so that brings us to use case 9. Let's generate some new fake logs. So that will be the end of the video. Definitely clean ending after UC8 and after getting all of this to run. So we're stuck at events DF. That takes a while, so I'll wait for that to finish out. And I'll leave the video running, but I'm gonna go get a drink. I'll be right back. Alright, so now that I'm back, this says finished running, and we're making it all the way down past the problem cell. But the problem cell, since it's errored out, it stopped the rest of the notebook from running. That's okay, it's just that one problem cell, so we're going to move on from that to the rest of the cells. And really what I want is the accuracy score, and I want to compare that to the score in the book. I think my accuracy scores will be a lot lower because this is the first notebook that's really put my resources to the test, and I really don't think I have enough resources to run this properly. But we will see if I can run it at all. And then of course I could set up my kernel differently. Okay, and we're skipping this cell because it's just too intensive. And now, the kernel. Okay, well, the kernel died even though I commented out this cell. So it actually appears to be that this cell here is causing it to die just as much or more than this cell was. So I think that's all I can do. It just requires too much horsepower for me. I should be running it in Google Colab Notebook as the author recommends, because then I can use the GPUs and TPUs available there. But as it is, running it on my own RTX 260 GPU, which can do games pretty well, but it unfortunately maxes out for AI applications at a point where I can't get this use case to work. So with that, I'm going to move on from that and stay tuned for use case number 9.